Good morning, students. So I think I have already sent you the slides regarding this. So I will try to give you the kind of overview of one of the topic on plant and microbial technique, and that is called as UV-VIS Spectrophotometry. A very small introduction. So we need to really understand first what exactly the spectrophotometer. As itself is consists of two words, spectro and then the photometer. So in the first case, you have to do the measurement of the light, that the spectroscopy, and then is the photometer. In a very simple manner, you can simply say that these instruments are used to measure the concentration. So it's like an indirect estimation. Measure the concentration of the solute in the solution simply by measuring the amount of light that is absorbed by the solution. So imagine if there is a solution, there is incident light, there is a reflected light, so it's like the percentage of absorbance. And it is used to measure the optical density of a given solution. So if you go to slide number 2, it's already explained here what exactly is the optical density. It is simply a logarithmic ratio of intensity of the transmitted light to the intensity of the incident light passing through the substance or the solution. Or in a more simpler way, it is simply say that it is the measurement of absorbed radiation or the absorbed light of the corresponding wavelength, and it could be simply measured in the form of optical density is equal to log IO I0. If you look here, so this is the cuvette. So any spectrophotometer is dependent on the three parameter: the incident optical density, the transmitted optical density, and what is the size of the path length. So it's totally dependent on the three parameter, this IO, I, and the path length. If you go to the next slide, we know that there are the three different lights. So one is the visible region, that it stands from 400 to 700 nanometer, and if any light is before the visible, that is ultraviolet, because it is before the violet, and if anything is after red, that is the infrared. So in a very simplified manner, these spectrophotometer, if you use the light source as a visible light, it is the visible spectrophotometer. If you use the UV light as a light source, it is the UV spectrophotometer. Nowadays, there are the more advanced instrument in which you can use the both, and these are called as UV-VIS Spectrophotometer. If you go to the next slide, it's normal history. It was first discovered in 40 by Ronald Beckman at NTL long back in. He was working in the company, the Beckman, in 1935. So if you look here, the principle. So any principle is simply based on the source of the light, and you can see here that is the collimator lens that make the light to pass through a single wavelength, and then you have this the prism. It will simply convert this visible length into the one wavelength, that is also called as the monochromator or the wavelength selector, and then it will pass through the sample, and then you have the detector, and then you have the observance. So before I say something, there are the two important law that is associated with the spectrophotometer. One is the Bayer's law. So Bayer's law is nothing. It is simply if there is any monochromatic light is passing through any absorbing media, its intensity decreases with the increase in the concentration. So therefore, intensity of the light is inversely proportional to the concentration of the absorbing media. And the next is the Lambert's law. Again, when there is any monochromatic light pass through the absorbing media, again its intensity decreases with the increase in the length of the light path, as what we discussed before, the path length of the cuvette. So again, it is inversely proportional to the length of the absorbing media. And if you combine both, so that is the Beer-Lambert's law. So in the spectrophotometer, the intensity of the light is inversely proportional to the length and the concentration of the absorbing media. So these are the two important laws that is you need to keep in your head if you want to measure the spectrum of any solution. And if I summarize here, so you can see here, this is the I naught, this is the I, and this is the path length. So the transmittance is simply the ratio of the intensity of the transmitted light to the intensity of the incident light, and you can easily calculate. And the absorbance is simply defined as the amount of the light absorbed by the sample. And again, you can simply calculate, as I told you before, in the logarithmic function, log 10 is equal to log 10 I slash I naught. So if we take two laws, and we can simply conclude that the absorbance, what I said, the intensity of the light is decreases with the concentration, increase in the concentration of the solute. However, the absorbance of the light, it means the light will be absorbed more if it has a more solute or the more concentrated solution. So absorbance of the light is directly proportional to the concentration of the solution. Secondly, the absorbance is also directly proportional to the length of the light path, that is the L in the form of the cuvette. So therefore, absorbance is directly proportional to the concentration and the length. So normally in the spectrophotometer, we measure the absorbance of the given sample. And as I told in the very beginning, so these consist of the two words, the spectrometer and the photometer. In the first case, it measures the spectra, and in the case of the other one, it simply measures the intensity of the light. And these are the three different components. So the first, they have to have a light source, then the collimator system, the monochromator, the sample compartment, detector, and the display. The collimator system, light source, it could be UV, it could be visible. The collimator system, it could simply make the light to pass in a single beam. The monochromator will allow to pass only one wavelength of light. This is also called as the wavelength selector. Then the sample compartment is the size, length of the path, and then the detector will convert into the intensity, and finally there is a display device. So what could be the different light sources? As I told you before, so if it is the UV, it could be hydrogen mark, deuterium lamp, the mercury lamp, and the xenon lamp, and mostly they can measure the sample in the range of 190 to 420 nanometer. If it is the visible, and sometimes the visible, the tungsten lamp measure both the power of UV and the visible, and range from 300 to 250 nanometer. So these are the some of the like a simple photographs. So these are the deuterium lamp, these are the mercury lamp, the xenon lamp, and these are the tungsten lamp. And these are the different collimator system that make the parallel by the lenses. And these are the monochromator. As I told you before, the monochromator, it is simply to convert into a single wavelength. The only thing you need to remember, what sort of the sample you're using. If you're using the UV light, then you have to use the quartz prism. If you're using the visible range, then you can using the normal the monochromator, because these are the monochromator, they play a very important role in the conversion of the single wavelength. Moreover, this diffraction grating is very important because these are present in most of the advanced spectrophotometer for a detection of a particular wavelength, and they are consist of the number of the line and the refracting the surface, which I just told you act like a prism. And as I told you before, the cuvette where you can keep your sample. So if you use the spectrophotometer, the cuvette could be quartz. You can't use the glass cuvette if you use the UV spectrophotometer. If it is the visible spectrophotometer, you can simply use the glass cuvette. And these are the different detectors. I can't go into very deep, but at least today you can understand. I mean, these detector will simply convert the radiant energy or the photons into a normal electric signal, and these are called as the BLC, photo cell detector, the photomultiplier tube detector, or the barrier layer cell. And These are, like some of the normal spectrophotometer. Some of are also available in our department. So I think I have already explained you before in our one of the Zoom class, but again I try to make it more simple so that you keep and record. I have already sent you the slides. Along with that, I will also send you the PDF of one of the UV spectrophotometer, so you can go through, and I hope it will be helpful. And if you have any query, you can directly message me, or you can send me an email, and I will be very happy to get your the question and send my feedback very soon. So have a nice day, keep studying, stay safe and healthy, take care, goodbye.